Thank you so much for tuning in to LearnLinuxTV, your source for Linux-related fun and learning. I love producing Linux-related content for you, but I can't do it alone. If the content on this channel has been helpful to you, then please consider supporting LearnLinuxTV. And one of the ways that you could do that is by becoming a patron, which will give you access to exclusive perks. Also, be sure to check out my latest book, Mastering Ubuntu Server 4th Edition. And while you're here, be sure to subscribe. New content is uploaded each and every week. Thank you so much for your support, I really appreciate it. Now, let's get started with today's video. Hello and welcome back to LearnLinuxTV. Of all the technologies that I've covered on this channel, Proxmox is among my favorites. But do you know what I also like? I also quite like Kubernetes as well. So how about we combine the two into one? How about we combine Kubernetes and Proxmox? Well, actually, that's exactly what we're going to do in today's video. In this video, what I'll do is walk you through setting up a Kubernetes cluster every step of the way. We're going to build the cluster completely from scratch, and it's going to be a lot of fun. But you still might be wondering, though, why would I use Kubernetes when containers are built right into Proxmox? Why not use the built-in solution? Is one better than the other? Well, actually, no. They're both great solutions, so I'm not going to tell you to use one over the other because ultimately it depends on your use case. But I know a lot of you are interested in learning Kubernetes, so that could be reason enough in and of itself. But even if not, Kubernetes is a ton of fun, and it's something that I recommend that you learn. Now, one thing I want to get out of the way first and foremost is that Proxmox is not actually required for this particular tutorial. If you have a virtualization solution of your own, maybe you're running something like VMware or one of the other technologies out there, the commands that I'm going to give you to build the cluster are the same regardless of what type of virtualization platform you might be using. Now, I will be using Proxmox to show you the examples in this video, but again, you don't have to have Proxmox. But what you will need are at least 2 virtual machines running Ubuntu Server. I have a video already on the channel that shows you how to install Ubuntu Server, and more specifically, I'll be showing you the process with Ubuntu 22.04. So that's what the virtual machines will be running that will ultimately be part of the Kubernetes cluster. Now, what I'll do on my end when we get into the tutorial is I'll be setting up some virtual machines that are running Ubuntu 22.04, and I'll be using the very same template that I've actually created in a recent video where I showed you guys how to use an Ubuntu Cloud image as a Proxmox template. So if you don't already have that set up, I recommend that you follow that video first because it just makes everything else that much easier. But even if you don't want to do that, you could just set up a few virtual machines running Ubuntu and you'd be good to go. But if nothing else, just follow along with me and I'll walk you through the process every step of the way. But before I get into that, I do want to mention something very important. And no, this particular video is not sponsored, but I do want to let you guys know about my latest book, Mastering Ubuntu Server 4th Edition. And Mastering Ubuntu Server is a book that I'm incredibly proud of, and the 4th edition is due out very soon. In fact, it might even be out already by the time this particular video is edited and released. Just like the 3rd edition before it, the new version will teach you everything you need to know in order to hone your Linux server management skills, but this time it's been fully updated for Ubuntu 22.04. In fact, this particular video was actually inspired by Chapter 18 from this book, and in that chapter, you'll actually learn about container orchestration. I worked really hard on this book, and I can't wait for you guys to be able to read it. And you'll be able to read it very soon. If you go to ubuntuserverbook.com, which is a special website that I've set up specifically for this book, you can find links to the various places that you can get it from. So definitely go to ubuntuserverbook.com and check it out. I would really appreciate it. So with that out of the way, what we're going to do is set up a Kubernetes cluster on Proxmox, and it's going to be so much fun. I'll have time codes down below, so that way you can go right to the section that most interests you or best reflects where you're at in the process. It's going to be a lot of fun. In the next section, what I'll do is give you guys more information about what you'll need to get started. I've already mentioned Ubuntu Server, so in the next section, we'll take care of that. And then as we go through the remainder of the video, you will build your very own Kubernetes cluster, and by the end of the video, you'll have a Kubernetes cluster that's all set and ready to go, and you'll be able to run your containers on that cluster. So let's go ahead and dive in. Alright, so in this section, what we're going to do is talk about what you need in order to get started. I've already mentioned that Ubuntu Server 2204 is going to be the base that we'll be building our cluster on. So you'll need at least 2 instances of Ubuntu Server, one for the controller and then another for at least one node. Now, if you want to set up additional nodes, I highly recommend that you do that because that's the power of Kubernetes. You can actually have your containers run against different nodes, and that helps spread the load. But either way, what you'll need at least is a virtual machine that will become the controller and a virtual machine that will become a node. Now, when it comes to how to spec these particular virtual machines, for the controller, I recommend at least 2 cores and at least 1 gig of RAM. Now, the 1 gig of RAM I just mentioned is a very, very low requirement, so you probably want to be closer to 2 gigs for, well, everything, even the nodes. If you can go even higher, that's even better. But actually, you probably shouldn't go too much higher on the nodes because the whole point of Kubernetes, again, is to have more than one node. So it's probably better to spin up more nodes than it is to give one node more RAM. But when it comes to the controller, you want at least 2 gigs. When it comes to the nodes, you want at least 1 gig or possibly 2, and that should be good enough. Now, for the individual VMs, they should be running Ubuntu Server 2204. Yes, it is absolutely possible for you to run a Kubernetes cluster on a different distribution. You can absolutely do that, and many people do actually do that. But I can't cover every single distribution in one video. I figured Ubuntu is probably a good way to get you guys started. And from there, if you want to experiment with other distributions, you could definitely do that. But the commands that I'm going to give you in this video were only tested against Ubuntu Server 2204. And like I mentioned in the intro, I'm not going to walk you through the process of installing Ubuntu 2204 because I've done that in a separate video. And in a recent video on this channel, I've also showed you guys how to use Ubuntu Server Cloud images to serve as a template in Proxmox. And I highly recommend that you do that first because when I go to create my instances, that's exactly what I'm going to do as well. I'm going to use that very same template. It just makes things that much easier. So if you don't have Ubuntu Server already set up, but you do actually have that template that we've created in that video set up on your Proxmox cluster, then you could follow along with me and I'll be using that same template. You'll see the process. If you're using something else or you don't want to create a template just like I've done in that video, then I'll leave it up to you to spin up Ubuntu Server on your own. Anyway, in the next section, what we'll do is we'll just walk through the process of using that template to spin up a couple Ubuntu Server instances, and then from there, we'll actually build a cluster. All right, so right here, we have my actual real Proxmox cluster. As you can see, I have 2 nodes in my cluster, PVE1 and PVE2. I'm not using high availability on my end because you need at least 3 nodes for that, but this cluster has actually served me quite well. And this particular implementation of Proxmox is going to serve as the example as I walk you through the process of building your own Kubernetes cluster. Now, if I expand this node right here, you can actually see that I have an Ubuntu 2204 template. As I mentioned earlier, I'm going to be using this template right here. This is actually from a previous video where I showed you how to use an Ubuntu Cloud image to build a template within Proxmox. Now, when I build a cluster, I'm actually going to have 3 nodes in my cluster. So for now, what I'll do is just clone this twice, and I think that'll be good enough until we need to have other machines later. So what I'll do then is right-click right here, and I'll click Clone. It can run on the same host. I think that's fine. So for the VM ID, I'll just give it 850. I want it to stand alone from the others, and I want them to be sequentially in order. You don't have to do that, and it really doesn't matter which ID you give it. You could accept the default, but I'll just leave mine at 850, because what that's going to do is it's going to place everything above the template, but after the most recent VM that I've spun up. So for the name, I'll call it K8S, the abbreviation for Kubernetes. Hyphen, then CTRLR, the abbreviation for controller. I think that should be good enough. And what I'll do is create this as a full clone, and then I'll click clone. And while that one's actually cloning, I'll just start the next clone in the process here. So I'll give it 851. For the name, I'll call it K8S-node. I think that should be descriptive enough. And just like before, I'm going to make it a full clone. And we can see on the left side there, it's actually building. Now there's some additional tweaks that we should consider for these particular instances here. So if we go to options, what we'll do here is we'll make sure that start at boot is enabled. I'm just making an assumption here, but I assume that if you're running a Kubernetes cluster, you probably want it to be running all the time. And also, you might want it to start up automatically when Proxmox itself starts up. I set the start at boot option in the template, so I didn't have to configure that. But that might be something that you might want to take a look at. For the start shutdown order, that might be something that you may want to configure, but I'm going to leave that alone, at least for this one. And then for the node, I'm going to check the same thing. It's set to start at boot. But for the start shutdown order, you might want to consider changing that for the node. So I'll click edit. And what I'm going to do is just give this a bit of a delay to ensure that the controller starts up first. Now there's no actual requirement for this. All the nodes will connect to the controller as soon as it's available. But in my opinion, it's good form to just have the controller be ready before the nodes are ready themselves. So what I'll do is just add a 15-second startup delay. That should be good enough. And I almost forgot to have you guys check the QEMU guest agent. This one right here, I recommend that you set that to be enabled. We'll install the QEMU guest agent later in the video. But it's a good idea to make sure that this is turned on, so that way when we install the guest agent, it'll already have the settings in place that it needs. So we'll just make sure that this is set to enabled. You could always click the edit button up here to change any of these options if you'd like. But so far, I think I'm good to go on these. So let's go ahead and start up the virtual machines then. We'll start the controller and the node as well. And we should see them start up right here. And it definitely is doing that. And this one is ready to go. Now, of course, we see Cloud Init is doing its thing, so we're going to wait for that to finish. And the same thing is probably happening here too, and it is. So on my end, what I'll do is I'll just wait for this to finish. And actually, it's done. The SSH host keys are regenerated at the end of the Cloud Init process. So what I should be able to do is press enter here and log in. So let's do that. And what we're going to do is run sudo apt install. And then the package is going to be qemu-guest-agent. So let's get that installed. And we could press enter for all of these prompts right here. We don't really care at this point. There's nothing really running on these particular servers yet. So that should be all there is for that. And then we'll go over here to the node instance here. And we're going to do the exact same thing. So I'll log in. And I'll install the exact same package. And it looks like the process of installing the QEMU agent is all set on this instance as well. And that actually concludes this particular section. I wanted to try to get all of the Proxmox specific steps done in one section, which I've done here. So in the next section, what we'll do is set up some preliminary tweaks within these instances to prep them before we install Kubernetes. And then after that section, we'll actually start building our cluster. All right, so in this section, we're going to do a little bit of preparation before we start building the cluster. Just some odds and ends that we want to make sure are taken care of on each of these instances before we build them into becoming what they're going to become. So the first thing I'm going to do is find the IP addresses of these instances. So in Proxmox, at least, I can click on Summary, and it gives me the IP address right here. So this one has an IP address that ends in 214. And the controller has one that ends in .213. So now that I know what the IP addresses are, what I'm going to do is SSH into these instances. So I'll switch to another workspace, and here I have the terminal. And I should probably open up another tab, so I'll take care of that. So what I'm going to do right now is SSH into the controller node. So the IP address for that, in my case, is 10.10.10.213. So now I have a session open to that particular server, and I'll do the same over here. And I typed in the IP address to the node instance. And we're connected. Now, the first thing that I want to do is actually install all the updates, but depending on how you have yours set up, you might not have to do that. With my templates, they actually use Cloud Init, and what Cloud Init does when an instance boots for the very first time is it makes sure that all the updates are installed. So I probably don't have anything, but it's a good idea to check anyway. I'll just run sudo apt update, ampersand, and then sudo apt dist upgrade just to make sure that everything is in fact installed. And there are a few packages here that have been kept back, but we're going to ignore those. And now the next thing that we're going to do is make sure that the controller has a static IP. Actually, you might want to make sure that both of them have a static IP, but what I'm going to do is make the second instance, the node instance, a template. So I'm not going to bother when it comes to giving it a static IP just yet, but I will go ahead and take care of that here for the main node, the controller node. Now, I always recommend static leases, DHCP reservations over static IPs, but depending on your configuration, that may or may not be a possibility for you. And I know a lot of you actually prefer the tried and true approach to creating a static IP. So what I'm going to do right now is walk you through the process. Now, later on, you'll need to do the same thing for the node instance as well. Again, I'm going to make it a template, which is why I'm not going to set up a static IP on that just yet. But let's go ahead and take care of it for the controller. So what we'll do is change directory into etc netplan. And there we have a file. That file name might be different for you. There are several different names that file can have depending on how you set up Ubuntu Server. So don't worry if this file has a different name on your end. That's perfectly normal. So what we should do is create a backup copy of that file before we modify it. So we'll just go ahead and copy this to the same name, but we'll end it in .bak. Just in case we make a mistake, we have something to go back to. And what we'll do is run sudo nano, and we will edit that file, the only file that's in that directory. And here we have the file. So what I've done is I've removed most of the configuration here underneath the ETH0 or ETH0 interface. And what I'm going to do is just hand type the rest of it. Now I will have a blog post that's going to be linked in the description below, which will have config file samples, and will also have any commands that I'm going to be using as well. So if you want to grab the sample file, you can do that. Just make sure that the interface name matches the actual interface name, otherwise it won't work. So for me, it's ETH0, but if it's different for you, then you can go ahead and change it. So what we'll do here is we'll type addresses. Then in brackets, we'll go ahead and place the IP address. In my case, it was 10.10.10.213 for the controller. I'm just using the same IP that DHCP would actually assign this anyway. On your end, just make sure it's outside of your DHCP range. On my end, I'm going to undo everything I'm doing right now and just stick to DHCP because I have static leases. But we want to make sure that we're using an IP address that's not used anywhere else. And we want to include a subnet identifier here, so /24 for my network. And then one level down, we'll just go ahead and line it all the way up here. We'll type name servers. We'll type addresses. And the name server in my case is going to be 10.10.10.1. Then we'll line up the next line with name servers, and we're going to type routes, then a hyphen, 2, and then default, the default route, and then via. So I've typed in the default gateway IP address, as you can see. In my case, it's the same IP address as the primary DNS server, so pretty simple. And what I'll do is save the file, Control-O, and then Enter, and then Control-X to exit out. And the next thing we should do is make sure that we test this. We definitely don't want to have a situation where the network can't come up because there's a syntax issue. So to test it and apply it, we can actually run sudo netplan, and then the keyword of try. We want to try it out. Now, if there was a syntax error, it would have told me, but there isn't one. So I'll just press enter to accept it. And believe me, if there's a problem, you would definitely know because it would tell you there's a problem and there'd be some kinds of error messages there. So If you see some errors, that must mean that you might have had a typo. Just be very careful. And if you don't see any complaints when you go to apply it, you should be good to go. Now, on my end, I mentioned that I'm using DHCP reservations. So what I'm going to do is just move the backup copy to the original file name to undo basically every change that we've made. Let's go ahead and apply that. And I'll press enter. And now I should be back to the default settings. Now on your end, if you are not going to actually create a template for your node instance like I'm going to do, then you can proceed to setting a static IP for that as well. Now another thing that we want to check is whether or not the hostname is set. Since I'm using Cloud Init with a Proxmox template, my hostname is definitely going to be set already. And to prove that, I could just cat the contents of etc hostname. As you can see, it's K8s-controller abbreviated. That's exactly what I wanted it to be. And if we take a look at the etc host file, let's see what's inside there. We can see the 127.0.0.1 localhost, that's there. But above that, we have 127.0.1.1, and it has the host name for the controller. If yours doesn't actually have the host name, then you would want to go in these files and make the adjustments accordingly. Now, the next thing that we'll do is set up a container runtime. That's something that we'll actually need because without a container runtime, well, we can't run any containers. So we may as well take care of that first. Now, going forward, each of the commands, unless I let you guys know otherwise, need to be run on every instance. So in my case, both the controller and the node. If you have more than one node, you'll need to run these commands on those as well. When we get to a point where anything is specific to the controller, I'll definitely let you know. So until then, just go ahead and run each of the commands that I'm going to show you on each of your instances. So to install the container runtime, what we'll do is run sudo apt install, and what we'll install is a package called containerd. I'll press enter, and then I'll go over here to the other tab. I'll do the same thing. And that one's done, and the controller is finished as well. Now the next thing we'll do is just check the status of containerd just to make sure that it's actually running. And I don't see any reason why it wouldn't be. We have yet to introduce any custom configuration at all, but we just want to make sure. So systemctl, status, containerd, just like that. And in my case, it's running. We see active and running right there towards the top of the screen. And anyway, it's running, so we're good. I'll press Q to break out of there. Let's check it on the other instance as well. And as you can see, it's active and running. Next, what we'll do is we'll create a brand new directory. So sudo mkdir. And the directory that we're going to make is underneath the etc directory. And we're going to call it, big surprise, containerd. And inside that file, what we're going to do is place the default configuration for containerd. To generate that default configuration, here's what we'll do. We'll run containerd, config default, and we'll pipe that into sudo t and then /etc containerd config.toml. And the T command is going to print the config to the screen, but also it's going to copy it to the file as well. We can see the file right there. So we'll do the exact same thing here on the node. And we now have that config file on both of these particular instances. And the default config is mostly okay, but there is one change that we'll need to make. So we'll run sudo and then nano. Let's edit that file. So now we have the file open on both of these machines right here. And specifically, there's just one option that we'll need to edit. And to make it a lot easier, we can hold Control and press W. And we can type part of the actual line that's before the line that we want to edit. And we could type run c.options. And that takes us right there. Let's go ahead and do that in the other one as well. So I'll search for the same thing. And if you scroll down just a little bit, once you found this particular line, we see an option here, systemd C group. We want to set this to true. And that's it. Control O and then enter to save the file. Let's do the same thing here. And let's save the file. And now that part's done. Now the next thing that we'll want to do is ensure that swap is disabled. And we can find out whether or not we have swap by typing free-m. And in my case, I don't have swap. We can see the last line is all zeros for swap. And the same thing is true here as well. Now normally swap is actually a good idea. But for our use case, we do want to disable this for Kubernetes. Kubernetes will actually yell at you if you have swap enabled, so we need to make sure that it's not. Now, depending on how you create your instance, you might actually have swap. And one way that you can disable swap is by editing the fstab file. So sudo nano etc fstab. And if you have a line in here for swap, you can comment that out with a hash symbol right in front of it. Obviously, I don't have swap enabled at all. I don't even have it listed here either, so I have nothing to do. I'm all set for that particular requirement. So I'm good to go on that. So next, we'll need to edit yet another file. So sudo nano, and this particular file is going to be under the etc directory. It's sysctl.conf. So that's the one that we'll want to edit. And what we're going to do is go all the way down. And we're going to look for this line right here, the IP forward line. And this is going to enable bridging. We definitely want to enable this, and we do so by simply uncommenting this line right here. Let's go ahead and scroll down and find it here as well. And here it is. And there we go. So next up, we have yet another file. And that's going to be a common thing in this tutorial. We have a lot of files to edit. So the next file is going to be under the etc directory, under the modules load directory, and the particular file is going to be called k8s.conf, just like that. And inside this file, we're going to type br_netfilter, and then we'll save it. And the same thing here. And I'll save it. And now we should have the bridge net filter enabled the next time we boot our instances. A full explanation of the bridge net filter is beyond the scope of this particular video, but a short summary of what it does is that it ensures that bridging is fully supported within the cluster. Sure, it's way more technical than that, but I think that's a good enough explanation. Bridging is critical in the cluster since it facilitates communication cluster-wide, so we definitely want to make sure that bridging is fully enabled. Anyway, at this point, we've worked through all of the preliminary tweaks that I wanted you guys to implement, so let's reboot these particular machines. And when these come up, we'll be ready to go. In the next section, we're going to go even deeper into the process of building a cluster. And this is going to be so much fun. So as soon as you've actually rebooted your instances and you confirm that they're back up and ready to go, we can go ahead and continue. All right, so in this section, we're actually going to install Kubernetes. In the previous section, we've implemented some various tweaks that we needed to support the cluster. And now that we have all of that set up, we should be ready to go to actually start the process when it comes to installing Kubernetes. So let's do it. Just to make sure we're on the same page though, you should have two instances running Ubuntu Server 2204. One of them is going to be the controller, and the other is going to represent a node. So on my end, I'll reconnect. to each of these particular VMs right here. And now we're in. So what we're going to do right now is install the repository that we'll need for Kubernetes. To support that repository, we will need the GPG key, so let's go ahead and install that. And all of these commands will be in the blog post that I'll have linked down below. So if you want to copy and paste any of these commands, you can feel free to grab them from that article. And as you're about to see, some of these commands are a bit on the longer side, so you might want to go ahead and consider copying and pasting the commands from the article that I mentioned. So on my end, I'll paste in the command right here. And what it's going to do is save it locally under the user share keyrings directory, and it's going to give it a file name of Kubernetes archive keyring.gpg. So I'll press enter, and that seems good to go. And I'll do the same thing here, of course. I want to make sure that each of these are consistent up to this point. And now we have the GPG key on both of these particular VMs. And the next command that we'll run is going to be a longer one as well. So I'll just paste it in. And this command will actually install the repository that we'll be pulling the Kubernetes packages from. Now, at least some of you that are paying very close attention will probably notice that the code name that it refers to here for the release of the distribution that it's for is Xennial, which is absolutely not the release code name for the latest version of Ubuntu Server. And yes, I am aware of that, but I'm also not in charge of what they call their repository. This is correct. I would really hope that they update the name, but they haven't done that, not even in the previous version of the book either. So that's the name, and this is the command right here to install the repository. And then we can run sudo apt update. Make sure that everything works and we have no problems, and everything looks fine here. Let's do the same thing again. We'll add the repository, and then we'll run sudo apt update. And now we have the repository. So next, what we're going to do is install the packages that are required for Kubernetes. So we'll run sudo apt install. The first package is going to be kubeadm. The second is the kubecontrol or kubectl package. And then the third one is going to be kubelit. But what do these packages actually do? Well, kubeadm gives us tools that we can use to bootstrap our cluster. For example, kubeadm is able to help us initialize a brand new cluster, and it's also able to assist us with joining a node to an existing cluster, as well as upgrading the cluster to a newer version down the line. kubectl is going to provide us with the kubectl command, and that's a command line utility that we'll use to manage our cluster and interact with it. You'll be seeing some examples of kubectl later in the video. The kubelit package is like an agent. It facilitates communication between the nodes, and it also provides us with an API that we could use for additional functionality. And sure, that was an overly simplified description of what these do, but I think that's probably good enough for us. Let's go ahead and press enter. Enter again. And I'll do the same thing over here as well. We'll wait for that to install. And there we go. Now, the next command that I'm going to have you guys run is actually specific to the controller. But before we get into that, what I'm going to do is take a quick break from building the cluster here, because I want to create a template of the node instance. That way, whenever I want to spin up another Kubernetes node, then all I have to do is spin up some additional VMs from that template. And considering that we have the Kubernetes packages and repository installed in this instance, then that's going to save us from a lot of work anytime we want to deploy a new node. Now, to do that, I'll run sudo cloud init and then clean. And to be sure that everything related to cloud init has been reset, I'll run sudo rm-rf. Be very careful with this command. And we'll run that against varlib cloud, then instances. And there's one more command that we'll need to do, and I'm not really sure why this is even necessary in the first place. The thing is, cloud init is supposed to reset the machine ID, but for one reason or another, it just doesn't do that. It might be something with the Proxmox implementation or something like that, but we could easily fix this particular problem. And the way we could do that is run sudo and then truncate -s and then 0. an etc machine-id. That basically erases everything within that file. The etc machine ID file, if you don't clear that out, then what's going to happen is every single instance you create from the template will have the same IP address. We definitely don't want that. Next, what we'll do is run sudo rm. We want to remove var lib dbus machine-id. So now that that's removed, let's go ahead and create a symbolic link. We'll link the etc machine ID file. Link that to /var/lib dbus and machine-id. Let's go ahead and just double check that. We can see that it links back to the etc machine ID, which is now empty. And now with that out of the way, we can go ahead and shut this down. So I'll do that now, sudo power off. Then back up here, we're just waiting for this node to shut down. And now it is. So what I'll do is convert this to a template. And as you can see, our node instance has been converted to a template. So what that should allow me to do is make some clones of this. Let's go ahead and see if it works. So I'll click clone. I'll give it an ID of 852. And what I'll do is just name this K8s-node-1. Make it a full clone. And I'll do it again. Just right click, clone. 853. Clone that. And one more time. Or however many times you want, it really doesn't matter. Whatever you have the resources for. And full clone again. And the next thing to do is to, well, of course, start up those nodes. But before I do that, I do want to make sure that I've set up the resources appropriately. I don't think I did, though. I almost completely forgot. So here we want to customize the specs for these particular VMs. Now I'm on the controller right now and it's actually running. So nothing that I set here will take effect while it's running. So I'll shut it down. We'll just go back over here. Let's power that off. We'll go back up to Proxmox. We'll wait for that to shut down. And what we'll do is set the RAM to at least 2048. Actually, I'm going to go with 4096 or 4 gigs of RAM. I think that actually should be more appropriate for something that's going to be doing a lot of work. For the CPUs, we want at least 2. And I'm actually going to set that to 4, just to make sure that this thing is not going to slow down at all. So that one's good. Let's go ahead and start this instance here. Now, 1 gig, 1 CPU is fine. Now, I'm going to set this to 2 gigs of RAM, though. I think that's actually fine for these. And for CPU, we may as well bump that up to 2 cores. This is up to you and your environment. The default of 1 gig and 1 CPU is fine. I have tested this with those specs, and everything worked just fine. So, same thing here. Now, you could even consider upgrading the memory to 4 gigs, but I think at a certain point, it just makes more sense to spin up more nodes than actually increase the memory. But if you do have a container that is very memory hungry, well, you might actually consider bumping up the memory. But I think the specs that I have here are probably fine for most. Let's go ahead and start these up. And we should see that Cloud Init goes ahead and does what it does, which it's actually already doing. We can see the output of Cloud Init actually interrupt the output of the boot process. That's perfectly normal. So let's go ahead and check the IP addresses just to make sure that each of the nodes has a different IP. So we'll check the summary here, and this one received an IP address ending in 215. This one received one ending in 218. And then we have one ending in 217. So that's pretty cool. So we have the node instances ready to go. We also have the template right here if we want to add additional nodes. So we're in a pretty good position right now. Let's go back to the actual shell, and we'll come back to the node instances later. But for right now, what we'll need to do is reconnect to the main controller node here. So let's go ahead and do that. So we're on the controller. And now what we're going to do is actually initialize the pod network. Now what I'm going to do is copy the command from the blog article, and you guys could do the same, but don't press enter just yet. We're going to paste the command into the terminal window, but there's going to be a few things that you'll want to change that will be specific to your environment. So I'll paste in the command, and here it is. So first of all, what we'll want to do is adjust the IP address right here and make this endpoint IP to be the same as the IP address for the controller. In my case, that's going to be 10.10.10.213. And for the node name, we'll want to make sure that it's the same as the host name for the actual controller itself. And in my case, the command I pasted had the wrong name anyway. We'll just set that to K8s-controller abbreviated, just like I've named the controller node here. And when it comes to this IP address right here, the last one, we definitely don't want to change that. If we do, then, well, things aren't going to work. You can customize the pod network, but I recommend that you don't, because there's going to be a lot of other things that you'll need to customize as well. And in that case, you are just creating additional work for yourself, so I don't recommend that. So let's leave the last IP address here the same. What this command will do is create and initialize our Kubernetes cluster. It'll also provide us with a command that we can use to join nodes to our cluster. So let's press enter after you ensure that the values match your environment to get the process started. We can ignore that warning that shows up right there. That's not going to slow us down at all. And like it says, it might take a minute or two, so we'll wait for this to finish. And now we actually have a real Kubernetes cluster. It's not really all that useful because we haven't even joined a single node to the cluster yet, but the cluster does technically exist, and that's a great step forward. Now what we'll want to do is copy the join command right here. So we'll just go ahead and highlight that, and I'll copy it. And what I'll do is open up a text editor. So I'll just open up gedit in my case, and I will paste the join command right here. Basically, what we want to do is just save this aside, this join command. We want to set it aside. We're going to need it later. We're not going to use it right now. As an aside, you definitely will not want to show the join command in clear text to anyone, especially not in a YouTube video that thousands of people are going to see. But in my case, I will be destroying this cluster and rebuilding it later, so technically this particular cluster will not exist any longer by the time you are seeing this video. So that's why I didn't feel any shame in showing this particular output, but just don't get in the habit of that. You definitely want to keep this private. Anyway, if we scroll up, we have the next three commands right here that we'll need to run. So you'll need to run this command here, this command, and all of these commands are being run against the controller at this time. So what I'll do is just paste in those same commands from the output. All you should have to do is scroll up to get those commands, or you could just get them from the blog post. These commands actually don't change from one installation to the next. And what these commands will do is give our local user access to manage the cluster. That's very useful. So the first of the commands was this one right here. And the second command was this one. Again, these commands right here were in the output when we initialized our Kubernetes cluster. And here's the third command right here. So we should be good to go on that. From this point forward, we should be able to manage the cluster without needing root. Our local user should have permission to do the administrative tasks that we'll need done. So far, so good. So now at this point, what we could do is run kubectl. This will be the very first kube control command that I've given you in this video. And we could check to see what pods we actually have within our cluster right here. So we'll just type kubectl get pods. And we'll want to check all namespaces. We have a handful that are running, so the two at the top are waiting on something, but what exactly are they waiting on? Well, they're actually waiting on an overlay network that we'll need to create. So let's go ahead and take care of that so we can make sure that the core DNS pods get what they need to be happy. And what I'll do is paste in the command right here. This will grab the Flannel overlay network configuration file or YAML file. This will actually give us what the core DNS pod is looking for. So I'll press enter. And well, the output there certainly looks promising, doesn't it? So let's run the previous command where we actually checked the pods in our cluster. And now we could see that the top two are now running. Sometimes it could take a little bit of time for that to happen. So if yours still says pending, just wait a few minutes and then come back and check it again. And when everything says running, like you see on my screen right here, then you should be good to go. Next, let's go ahead and join some nodes to our cluster. If we run kubectl get nodes, then all we're going to have is our controller here because we have yet to add a single node to our cluster. So I'll switch over to a new tab here, and I'll connect to the first of the nodes that we'll want to use. So for that one, I'll go ahead and SSH as myself, then .215 for the IP address for the first of the nodes. We'll say yes. And here we have node 1. So in another tab, I'll do the same thing. And the second, if I remember correctly, ended in .218. And there it is. And then let's connect to the third node here. And that one I believe was 217. Let's see. And there it is. Now we're connected to each of the three nodes that I've cloned from the template. And what we're going to do is join these particular nodes to the cluster. And let's get that process started. So what I'll do is just go back here to the very first node, and let's grab the join command that we set aside earlier, and I'm going to paste it right into this particular terminal window. We will need sudo, so I'll type that in first, and then I'll paste in the command. And there it is. So I'll press enter, and it looks like we have an error here. And what this usually means, at least anytime I've run into it, is that too much time has passed from when the join command was generated. There is a time limit on that. So what I'm going to do to attempt to fix this is paste in this command right here. So it's kubeadm token create and then print join command, just like you see on the screen right now. This will regenerate the actual join command that I'll be using. So let's see if this fixes the problem. So I'll press enter. And here we have a join command. So I'll grab that. And then we'll move over to the other tab here. So what I'll do is type sudo and then paste in the command. And here it is. And let's see what happens. Well, that's certainly a lot more promising, isn't it? So let's go ahead and just, well, run this on the other nodes as well. Let's see what happens. And so far, so good. The output is definitely a lot better. So let's run kubectl get nodes. We can already see that two of the nodes are starting to check in. They're not ready quite yet, but they are in the process of becoming ready. So we can go through and look at the process. Looks like that one's done. So is that one and that one. So sometimes it just takes a few minutes for everything to become ready. So let's run the command again and see if the status has changed. And yeah, we can see that there's been some changes. The first two nodes are ready, and the third one is still in the process of becoming ready. So we can simply just keep running this command over and over again until they're all ready, and now they are. So as you can see here, we have 3 nodes in the cluster. And again, if the join command that you have actually timed out, then this is the command right here that you would run to regenerate that to get the other nodes added to the cluster. But each of the nodes are added to the cluster. So at this point, we're actually completely finished. We have a Kubernetes cluster. But you might be wondering, well, what can I do with that cluster? How do I run something on that cluster? Well, in the next section, what I'm going to do is show you a quick example of running an nginx container and also a nodeport service that'll give you a start, at least, when it comes to running things on your cluster. All right, so in this section, what we're going to do is actually launch a container within our cluster. And to do that, we'll create a YAML file. And inside that YAML file, there's going to be some instructions that will pertain to Kubernetes to tell it how to run that container. So I'll just use nano, and I'll call it pod.yml. So we have an empty window right here. And what I'm going to do is paste the contents that should go inside this file. And here it is. So I will go over this fairly quickly. A full walkthrough of Kubernetes YAML files is beyond the scope of this video, but this one is pretty simple though. So API version 1, we're going to leave that alone. It needs to be set to exactly that. The kind is set to pod. We want to create a pod. And in case you didn't already know, a pod is what containers run inside of when it comes to Kubernetes. So we need to create a pod. We can have other containers in here as well, but we're only going to have one. We're going to be launching nginx. For metadata, I'm setting the name as nginx example. That's just the name of this particular deployment or this particular pod. Labels are a key value pair. So I'm creating a label called app, and I'm setting that equal to nginx. Then we have the spec section. So we're setting the specifications for the container that we want to create. So we're going to pull the nginx container. We're going to grab that from the Linux server registry. That's at linuxserver.io if you didn't already know. And there's a container called nginx. So we're going to grab that. And if you're curious why I chose linuxserver.io, well, other than the fact that it's an awesome registry, they also have some Raspberry Pi compatible containers there too. Actually, I think all of them are. So even if you are running a Kubernetes cluster on Raspberry Pi, as we've done on this channel before, then you'll be well served by linuxserver.io. But even if you're not using Raspberry Pi, it's still fine because they have x86 containers as well. So we're setting a container port of 80. That's the default port for nginx anyway. And we're applying a name to that port of nginx HTTP. So let's save the file. And we have our YAML file, our pod config file, if you will, right there. So let's go ahead and apply it. What we'll do is run kubectl apply -f, and then the name of the file. And if this works, it should actually deploy a container into our cluster. Well, that was simple. It just tells me that it was created. But let's go ahead and take a closer look at that. What we'll do is run kubectl get pods. And we can see that the nginx example pod right there is ready to go already. Another thing that we can do is add another option here. So we can add -o and then wide. And that also tells us which node that particular pod is running on. So it's running on node 1, in case you were curious. But anyway, we actually have a real pod and container running in our cluster. That's awesome. But one thing we can't really do, at least not yet, is we can't access that container, at least not normally. The pod network is actually segregated, and there's no door, so to speak, that we can go through to access the container from our local network. We'll need to set something up to achieve that. But there is one way that we could actually test to make sure that it's working. So let's run kubectl get pods again, -o and then wide. And we have the IP address there. So what we could do is run curl against that IP address. That's an IP address within the pod network. So we'll just type it in as is and press enter. And check this out. We have the HTML for the sample page that comes with the nginx container, which means it's actually working. But wouldn't it be a lot better if we could actually access this from a web browser on our network? I mean, that's kind of the whole point, right? Well, let's go ahead and set that up. So again, we'll create another YAML file. We'll call this one service-nodeport.yml. And just like before, I'll go ahead and paste that right in here. So as you can see from the second line, what we're doing right now is we're creating a service. There's different types of services, and a full walkthrough goes beyond the scope of this video, but I plan on covering Kubernetes in more detail anyway, later in the life of the channel, so stay tuned for that. We're going to give the service a name of nginx example, and the type of service that it is a nodeport service, and what we're going to do is map port 80 to nodeport 30080. Now, port 80 is the port that the nginx container itself is using. Port 30080, which I've chosen at random, actually, is going to be the port that we'll use to access the container from our local network. So we're pointing that over to the nginx HTTP port declaration that we've added in the previous file. And for the selector is the label that we created earlier, the label we called app that we set to nginx. Anyway, let's save this file. Just like before, what we'll do is run kubectl apply -f service nodeport.yml. So let's apply it. Now to check the status of that, we can run kubectl, get, and then service. And we have our actual node port service there at the end of the output. We can see that port 80 is mapped to port 30080. So this should actually expose the container to the remainder of the network. So what I'll do is just open up a fresh web browser here. And what we'll do is we'll type in the IP address 10.10.10, and then it was 215 if I remember correctly, and then port 30080. And we actually have right here the default start page or the example page for nginx, which means it's working. But out of curiosity, what happens if I change the IP address here to end in .213? If you recall, that's the IP address to the controller. What's going to happen? Well, let's find out. It still works. Okay, well, what if I put in the IP address for node 3? It's not even running on node 3, so this is going to fail, right? No, it works fine. Well, actually, that's how Kubernetes works. You could actually type in the IP address for the controller or one of the nodes, and it's all the same, because that particular node port service is mapped to port 30080, and that's cluster-wide. And the beauty of this is, well, you can access this from any of the IPs that are associated with the cluster. That's pretty cool. But what this does is it proves that our cluster is actually working. So congratulations, you have a fully working Kubernetes cluster. And if you're like me and you ran this in Proxmox, then you have it running in Proxmox, and that's pretty cool. So there you go. And that brings us to the end of this video. Thank you guys so much for checking out this video. I hope you had a lot of fun. I always have fun when I'm working with Kubernetes. It's just so cool. So definitely subscribe if you haven't already done so, because there's some additional tutorials coming very soon, and I can't wait for you guys to see them. I'm not going to spoil the surprise, but definitely some really cool things. So click that subscribe button, and if this video has helped you out, then also click that like button as well. Anyway, again, thank you so much for watching, and I'll see you next time.